In lesson 5, we're going to look at how to factor trinomials. So if you remember, trinomials are polynomials with 3 terms. And kind of the rule for this is that we have to have the first term being an x squared, and then the middle term is just going to be like an x value, and then you're going to have some number at the end. And there's a pattern here when you're looking at factoring trinomials, is that you always have to add to this middle term and multiply to the number that's going to be at the end. And that's going to be how you're going to figure out these a and b values, or the numbers that you're going to use for the factors. So let's look at some examples here. So here's a trinomial in the form x squared, x, and a constant. So this is called a quadratic trinomial. It's in a quadratic form. And the leading coefficient of this trinomial is 1, because if you look at the number in front of x squared, it's really just a 1 there. So what I'm looking for are numbers that add to 8 and multiply to 12. So I always remember it as a comes before m in the alphabet, so add, then multiply. So the 8 is what we're adding to, the 12 is what we're multiplying to. And what you're going to have is 2 sets of parentheses, and you're going to have an x and an x, because you have to be able to multiply to get x squared. And you have to ask yourself, well, what numbers are going to multiply to 12? So think about the factors of 12. So you could do, so I have the factors of 12. I would have 1 and 12, 2 and 6, and 3 and 4. So 2 and 6 are going to be the numbers that are going to work, because they're going to add to 8 but multiply to 12. So it's going to be x plus 2, x plus 6. So that's it for that. And basically what we're doing here is we're doing the opposite of what we did in the previous lessons, where in one of the lessons you saw multiplying binomials or multiplying polynomials. We're basically trying to find, like when we factor, you're trying to figure out what were the 2 polynomials that we multiplied together to get this expression. So I'm trying to undo the process of multiplication. I'm trying to come up with, what do I need to multiply together to get this x squared plus 8x plus 12. So we're undoing that process of, trying to figure out what has been multiplied. So in this case, what has been multiplied, x plus 2 times x plus 6. If you ever wanted to check your answer, you could draw your box and do x plus 2 times x plus 6, and you should get out x squared plus 8x plus 12. That means we've done it correctly. Let's try a couple more examples like this. So this example down here, again, add, multiply. So we're going to have 2 sets of parentheses. We're going to have x and x, because we're trying to get that x squared. And now we need to add to negative 2, but multiply to negative 15. So think about the factors of 15. So we have 1 and 15, and 3 and 5. And we have to be able to add to a negative. So since we're multiplying to a negative, that tells me right off the bat I got to have opposite signs. The only way to multiply to a negative number is if you have a positive and a negative. And since I'm trying to also add to a negative, that tells me that the bigger number is going to have to be negative. So the only numbers that are going to work here are going to be 3 and 5. And the bigger number would have to be the negative number, because when I add 3 to negative 5, it's going to stay negative. So my answers here are going to be negative 5 and positive 3. And again, you could check it by actually multiplying it, and you'll see that you'll get what we started with. So let's look at some more. So this example here is a little bit different. It's still in that quadratic form, but now we have a second variable involved. We have a y involved. So all that means is I can still apply quadratic factoring to this, or the quadratic trinomial factoring. The only difference is when I set it up, I always put my x's first, because I'm trying to get an x squared. But I also have to put y's over on the right side of my factor, because I need to be able to get a y squared when I multiply that last term of each binomial. So that's all really I need to worry about, is if you have an x squared, put that x and x, and then the y squared, you got to just get your y's in there as well. So now it's still going to apply. We're going to add, multiply, and when we're adding, we're really adding to a negative 1 because that's the number in front of xy, and multiplying to a negative 12. So again, I'm multiplying to a negative. That tells me I'm going to have opposite signs. And now I'm looking at my factors of 12. So 12, I have 1 and 12, 2 and 6, and 3 and 4. You don't have to write out your factors. It's just that helps you. So the only way that I can combine any of these numbers and get a negative 1 is if I use 3 and 4. So if you remember, if I'm multiplying to a negative, it's opposite signs. But then if I'm also adding to a negative, I have to have the bigger number being negative so that when I add the smaller number, it still stays negative. So it's going to have to be minus 4 and plus 3. So just notice that my final answers are actually x plus 3y, x minus 4y, and again, that'll help get that middle term of x times y, because when you multiply your outside terms and your inside terms here, you're going to get that xy, and then you're going to get the y squared when you multiply the 3y times the negative 4y. So that's it. That one's done. And then let's look at one more with a leading coefficient of 1. So I look at this example, and you try to figure out some numbers that are going to add to negative 8 but multiply to 6. And in this case, you can't figure out any numbers that are going to work. So what that means is there aren't binomials that are going to multiply to give me this with whole numbers. So we're just going to say that this is not factorable. And this can happen where you go to factor something and it doesn't actually factor. And we'll talk about how to divide polynomials in a couple of lessons coming up in the future. But for right now, we're just going to leave this and say it's not factorable. So really what this is called is a prime polynomial. So it's not factorable, so this means it's called a prime polynomial. So meaning there's no numbers that are going to work as factors here. So we're just going to leave it as is and move on to another problem. But I just wanted to show you that so you know that that can happen. So let's look at some other examples now where the leading coefficient is not equal to 1. So the leading coefficients in these problems are not equal to 1. So your first thing is you always want to look for GCF, because sometimes you can factor out that leading coefficient and then it becomes the problem similar to what we just did. So let's look at this first example. So when we look at this term here, our leading coefficient is not equal to 1. So if I can take a 3 out of every piece, that's going to be beneficial. It'll make my problem a little bit easier. But you also always want to check for any kind of GCF. In the last 4 problems, I actually did look for GCFs. I just didn't say I was looking at it. But you always want to get in the habit of looking for GCFs. If you see them, you want to factor them out first before you simplify any further. So when you look at this, yes, I see 3 is a GCF, and usually that's a good indicator. Whenever you have your leading coefficient not equal to 1, that's usually a good indicator that hopefully there's GCF in there. But also check the variables here. It looks as if I can pull out an x squared from each piece, because I have an x to the fourth, an x to the third, and an x squared. And that's about it though, because if you look at the y's, I don't have a y term in each piece. So remember, when you do GCF factoring, you always have to rewrite first with that GCF out in front, and you're going to have one set of parentheses. And now what you're really doing is you're thinking about dividing each of these terms by 3x squared. That's essentially what we're doing. So we're dividing everything by 3x squared. So here, when I divide by 3x squared, the 3's cancel, and I'm left with x to the second. And then here, the next term, I'm going to have minus 5x. And then the last term will be minus 6. And my x squareds are going to completely cancel, and I'm going to have a y squared. So now you always check, can I factor what's in parentheses? And the answer is yes, you can. It's actually a trinomial where we can apply quadratic factoring. Just keep in mind here, oops, I forgot to carry my y, just don't forget about that. This y up here, I missed it. So just keep in mind when we do quadratic factoring, it might not always be in one variable. This one's in two variables. So basically, we have to have our squared terms in front, squared terms in the back here, and then we have to have our um, variables that are just raised to the first power in the middle. So I'm going to go ahead and I'm going to keep my GCF, and I know that this other part's going to go to two sets of parentheses now since it's going to be quadratic. And I'm looking for adding and multiplying to these two numbers. And remember, it's going to be x and x because it's an x squared in the front, y and y because it's a y squared in the back. And the reason why this is quadratic factoring, though, is because it's an x squared and it's a y squared in the two outside terms, but the middle here is just the variables raised to the first power. That's actually how I knew that I messed that up when I looked that I forgot that y, because in order to do quadratic factoring, I have to have an x times a y in the middle. So now I can look at add multiply. So I need to multiply to 6. So I have 1 and 6 and 2 and 3. And I need to add to -5. Keep in mind you're multiplying to a negative, so that means opposite signs. We're adding to a negative, which means the bigger number has to be negative. So the only way that we can combine these numbers over here and get 5 is if we use 1 and 6, where one of them will be negative and the other one will be positive. You can use 2 and 3 to get 5, but the problem is we need them to be opposite signs, and if 2 and 3 are opposite signs, they're not going to give us 5. They're going to give us 1. So we have to use 1 and 6, and the negative is going to be the 6, and then the positive is going to be the 1. So you have -6 plus 1 will give me -5, and they'll multiply to -6. Now I can rewrite this without that 1. I don't really need that 1, so it could be x plus y times x minus 6y. And again, you can multiply it out and just double check that it actually does work. Keep in mind too, it doesn't matter the order that you write these factors. So like if I wrote x minus 6y and then x plus y, that's absolutely fine because multiplication is commutative. So now this next set of problems is what happens when we can't factor out that GCF or factor out that leading coefficient as a GCF. So when you look at this example here, see how I have a leading coefficient other than 1, which is 3. But 3 is not a GCF. I cannot factor 3 out of all 3 pieces. So what that means is we have to do what's called factor by grouping. So this is where you're going to multiply these two terms, the a and the c term, or the number in front of x squared and the constant term. So we get -6. So that means I need to multiply to -6, and we have to always add to that middle term. So we're going to add to -1. So it's still going to be kind of that same process where you're adding to the middle, but in this time, instead of multiplying to just -2, it's got to be multiplied to -6. So we have to use either 1 and 6 or 2 and 3 to do so. And if we're multiplying to a negative, that means you're going to have opposite signs. And if you're adding to a negative, the bigger number is going to have to be negative. So I can use 2 and 3 to get -1 by making the 3 negative and the 2 positive. That's how I'll be able to get my -1. So what happens is I'm going to use those two numbers, and instead of just doing two sets of parentheses right off the bat and getting your factors, this process is a little more complicated because what you need to do is you need to rewrite this polynomial so that it has 4 terms so that we can then apply factor by grouping. So what we're going to do is I'm going to rewrite, so I have 3x squared minus 3. See how I have a minus 3 here? But in the middle, I have a minus 1x. So it's really going to be minus 3x plus 2x minus 2. And the reason why this works is because this piece here is really the same thing as what I had. I'm just basically, instead of simplifying, I'm kind of making the expression more complicated so that I can have 4 terms and so that I can factor by grouping. So I basically just rewrote this negative 1x as minus 3x plus 2x, which is why I find these two factors, but then when I write them in here, I have to make sure that I put the x's with them because of the fact that there's an x in this original expression. So you find your factors the same way, or you find your numbers the same way. It's just here you got to remember to write those x's. And now I can split it down the middle since there's 4 terms and find a GCF out of each piece. And keep in mind too, notice that I use the negative 3 first and then the plus 2x. The reason why I did negative 3 first is because I looked ahead and saw that I would be able to factor out a 3 if I use 3, since I have a 3 first and a 3 second. And then down in the back of this, I have a 2, a minus 2, so that's why I wanted my 2x to be grouped with that minus 2. So now I'm going to factor out my GCF in the front, which is actually going to be 3x. You can take a 3x out of each piece. So I'm going to be left with an x minus 1. So this is something that we did in the last lesson, factor by grouping. And now remember, you always want that middle term, or that x minus 1 again, to happen when you take out the GCF in the second piece. So if I take out a 2, a positive 2, so I put plus 2, I would have an x minus 1. And now what I can do is I can take out this entire binomial factor. So I can take out an x minus 1. And you're left with, when you do that, so if this is gone, I'm left with a 3x. And I'm left with a plus 2 on the other side. So there are my new factors. And if you multiply those out, you should get 3x squared minus x minus 2. So here are the factors. And notice that because I had that 3x squared, that's why I have a 3x now instead of just like an x plus 2 and an x minus 1. So let's do some more of these just to get familiar with it. So this next problem here, you look at it and you see, okay, well, I have a leading coefficient that's not equal to 1. So see first if you can factor it out. Unfortunately, in this case, you can't. So what I'm going to do is I'm going to multiply those, and I'm looking for numbers that are going to multiply to negative 24, but they're going to have to add to negative 10. That's what I'm looking for. So numbers that multiply to negative 24, but add to negative 10. So 24, I have 1 and 24. Notice I'm not putting the negatives because we'll figure that out when we do the add part. 2 and 12, 3 and 8. I always just go in increasing order. So like 1 times 24, 2 times what? 3 times what? 4 times 6, 5 doesn't work. And then you get back to 6, 6 times 4, and then it just starts repeating. So that's how I know I have all my factors. And I'm trying to add to negative 10. So since I'm multiplying to a negative, I know that I have to have opposite signs. And in order to add to negative 10, the only way that I'm going to be able to do that is if I use 2 and 12. And 2 is going to be the positive number, and 12 has to be the negative so that it stays negative. So here are my two numbers. And remember, it's not going to be x plus 2, x minus 12, because I got these numbers knowing that I had a leading coefficient not equal to 1. So this is where we have to make the expression more complicated and rewrite that middle term. So instead of minus 10x, I'm going to make it plus 2x minus 12x. Now looking ahead, you want to be able to group the terms so that you're going to be able to pull out a GCF. So basically, if I put minus 12x first, I'll be able to pull a 3 out of those. So I'm going to do minus 12x and then plus 2x minus 8. So notice how I switched the order, and that's strictly just because of what terms I'm putting them next to. I know I'm going to have to be doing a GCF factoring. So I put the 2 with the 8 so I can pull out a 2, and the 12 with the 3 so that I could pull out a 3. Now that I have my 4 terms, also notice that this stayed the same. Minus 12x plus 2x is the same as minus 10x. So I didn't change the expression, but now that I have my 4 terms, I can split it down the middle and do factor by grouping. So out of this first piece here, we can factor out a 3x. So I'm going to be left with an x minus 4, which tells me that in my next piece, I need to get that x minus 4. And it looks like I could pull out a positive 2, so it's going to be plus 2, x minus 4. So now I can pull out the x minus 4, since it's the same. And when you do that, you're going to be left with, so when this is gone, you're going to be left with the 3x. And when this is gone on this side, you'll be left with a plus 2. So then there are your 2 factors. Keep in mind too, this like plus 2, it's always going to be in this stage where you have your binomial factors, so in this middle step, you should always have like a plus or a minus sign between the 2 terms, because we just split this up, where I'm really looking at this as here's 2 terms, so I have 2 terms that I'm doing a GCF factoring to, plus 2 more terms that I'm doing a GCF factoring to. So it's really like 2 separate pieces. And then you look at it as a whole, and since you're factoring out an x minus 4, a GCF factoring, so this is like my GCF, then you always are left with one set of parentheses, which is why the operation then becomes multiplying, because you're really doing a GCF factoring. You have one set of parentheses left, you're taking out the GCF. All right, a couple more. So looking at this one here, again, you're looking for a GCF first, and we do not have a GCF. Notice that this one has an x squared, an xy, and a y squared. So it's still in that quadratic form where I have my squared terms in the front and in the back, and then in the middle I have the just the x and y terms. So it's going to be the same concept. The only difference is we're going to have some y's in there. Remember, we should have y's at the end of each of my binomial factors. But we're going to start it off the same way, where we're just going to focus on the numbers, and then we'll worry about putting that y in there as we do the problem. So I'm looking for numbers that multiply to 30, and they have to add to 13. So 30, I have 1 and 30, 2 and 15, 3 and 10, 5 and 6. So the numbers that are going to work here will be 3 and 10, so that I can add them to get to 13. So it's going to be plus 3 and plus 10 that'll work for this. So over here in my problem, I'm going to rewrite these, but keep in mind I'm looking at the factors that they're going to go with, or the numbers that they're going to go with. So I want the 3 actually to get grouped with the 15, so they have a common factor, and the 10 I'm going to group with the 2, so that there's a common factor between those. So it's going to be x squared plus 10, and you're going to keep those xy's so that you're not changing the expression any, plus 3xy plus 15y. So now we can split it down the middle. We can do GCF factoring since we have 4 terms. So we can factor out a 2x out of the first term. So we're going to have an x plus 5y, which means that in my second term I should have an x plus 5y left. So it looks like I can factor out a 3y for GCF. So I'm going to have x plus, and I'm going to have 5y left, so that's good. So now I can take and I can factor out an x plus 5y out of both terms. So I'm factoring this out of both pieces. So when I get rid of it in the first, I'm left with a 2x. Remember, it becomes multiplication now because you're really doing a GCF factoring. One set of parentheses and you're pulling out a GCF, which happens to be a binomial in this case. So then I'm left with a 3y in the second term. So then that's it. So it's the same concept, it's just now you got those y's in there at the end. Alright, two more. So this example here, notice that we have a higher exponent. So we have an x to the fourth. However, this is still in quadratic form because this term in front, this variable, has been squared in comparison to the variable in the middle. Previously, we always had x squared in front and then just x in the middle. So basically, the variable in the middle is always the square root of the variable in the front. So that's kind of how we know it's quadratic factoring. And what we're going to do is we're going to look, okay, well, I have a leading coefficient that's not equal to 1. So we can't take it out as a GCF, so we're going to multiply it. So we're looking for numbers that are going to multiply to 72. So 12 times 6 gives me 72. So we have 1 and 72, 2 and 36, 3 and 24, 4 and 18, 6 and 12, and 8 and 9. Then I'll start repeating. And they need to add to 17. So again, I'm looking at the numbers in the same way. Multiply to 72, add to 17. The only difference is when I write my expressions, I'm going to have an x squared in the front of both terms because really what goes in the front of each piece is the square root of that leading coefficient. So adding to 17, the only numbers that are going to work for that are going to be 8 and 9. It's going to be plus 8 and plus 9. So then I'm going to rewrite my expression. So I'm going to have 12x to the fourth. And I'm going to group the 8 or 9 with this. It's not going to make a difference because I could either pull out a 3 or I could pull out a 4 if I use the 8. So it's not going to really matter. If you look at the last term here, the 6, you could pull out a 3 if you use 9, or you could pull out a 2 if you use 8. So it's not going to really make a difference. So I'm just going to stick with the order I have. So 12x to the fourth plus 8x squared plus 9x squared plus 6. Now we can split it down the middle, pull out a GCF. So I'm going to be able to pull out a 4x squared. So I'm going to have a 3x squared plus 2. And then over here, my second half, I'm going to be able to pull out a 3. So I'm going to have 3x squared plus 2. And again, remember, these factors here should be the same. If they don't show up to be the same, that means you're doing something incorrectly and you just want to go back and check. So now I can factor out that GCF, and I'll be left with one set of parentheses, which will be 4x squared plus 3. And one last example here. So this example here, when you look at this, hopefully you recognize like a pattern or something going on here where I have a binomial that's actually the GCF. So I have a x minus 3 in all of these terms. So the first thing I want to do is I want to do a GCF factoring, which means one set of parentheses and pulling out that x minus 3. So I'm going to have 2x squared when I take the x minus 3 out, minus 5x minus 3. So that's the first piece. I did GCF factoring. And it was kind of unusual because I'm taking out a binomial as my GCF. And now I look at what's left, and I have a quadratic. I have an x squared, an x, and a number, but I have a leading coefficient that's not equal to 1. So that tells me I'm going to have to use factoring by grouping. So I have to multiply to negative 6. but add to -5. So adding or multiplying to 6 is going to be 1 and 6, 2 and 3. And if I'm multiplying to a negative, that means I have to have opposite signs. Adding to a negative means the bigger one's got to be negative. The only numbers that are going to work here are going to be 1 and 6. If I'm trying to get -5 but have opposite signs, I have to use 1 and 6, and it's going to have to be +1 and -6. So these are going to be my numbers. I'm going to rewrite. So I'm just going to kind of carry along this x minus 3 out in front. And now I'm going to rewrite that middle term. And when I rewrite the middle term, it's not going to really matter which one like if I use the +1 first or the -6 first. So I'm just going to keep it in order here. So I'm going to do +1x minus 6x minus 3. Again, I'm carrying that x minus 3 out in front. And now I can do factor by grouping for this part here. So I can take out an x out of the first piece. So I have a 2x plus 1. And now here, notice that I have minus minus, or a -3 is really the important part. But I need it to be a plus because it has to be a +1 when I'm left, like what I'm left with. So that means I'm going to have to factor out a negative. So I'm actually going to factor out a -3 out of both terms, so that I'm going to have 2x plus 1. So keep that in mind, that whenever you look at this second term here, if you have a minus but up in front you have a plus, that means you're going to have to switch your signs. So now I can factor out this piece here. So I just carry down the rest, x minus 3. So I have a 2x plus 1. So I have x minus 3 left when I factor out 2x plus 1. And notice I have these extra parentheses. I don't really need those extra parentheses here. I could just leave this as x minus 3 times 2x plus 1 times x minus 3. And I actually can shorten this. Since I have two x minus 3's multiplied together, I can just write it as x minus 3 squared times 2x plus 1. So since I'm multiplying an x minus 3 times an x minus 3, the shortened way would just to be x minus 3 squared times 2x plus 1. So that's it for trinomial factoring. And just keep in mind, factoring by grouping can work whenever you have a leading coefficient not equal to 1. If you have leading coefficient equal to 1, you just go right into your two binomial factors.